Assalamualaikum dear students. How are you all? I hope you all are fine. I am Ms. Soeba Ghayas. Today I am going to give you presentation of chapter number 2, that is particles. This is chapter presentation number 2. In this presentation I will explain you from page number 82 and 83 from your book, and after the explanation I will give you written work of question number 1 till question number 3 of long question answers. Now, first topic is model of particles in solid. Strong forces of attraction hold the atoms or molecules close together in rows. The particles vibrate, but they are not able to break free. This is why solid has a fixed shape and volume. Model of particle in a liquid. Atoms and molecules are held close together but are not tightly nor in any particular pattern. They have enough energy to move about more than in a solid. This is why liquid can flow. At the surface, the particles attract one another, forming a kind of skin over a liquid. Model of the particle in a gas. Atoms or molecules are far apart and move so quickly that they do not really attract each other. They move in straight lines and frequently collide with each other and the walls of the container they are in. The large distances between gas particles mean that gas can be squashed or compressed easily. Evidence that particles exist. Have you ever noticed how a balloon always goes down after a while? No matter how tightly the balloon is tied, the air inside always seems to escape. This is because the skin of the balloon has millions of tiny holes in it. The molecules in the air are small enough to pass through these holes, and so the balloon deflates. Evidence that particles are always moving. When you take the cap off a bottle of perfume, the smell gradually spreads out. After a few minutes, the scent can be detected several meters away. This is because some of the perfume molecules have escaped and moved across the room by colliding with moving air molecules. One substance spreading through another is called diffusion. The random motion of particles is called Brownian motion. It is named after a Scottish scientist, Robert Brown. In 1827, Brown noticed that pollen grain moved jerkily when placed in water. In this case, the tiny pollen grains were being bombarded by moving water molecules. Now it's time for written work. You have to do these long question answers, question number 1, 2 and 3 in your journals. You have to maintain your journals regularly. I will check your journal. It's time to say goodbye. Thank you and Allah Hafiz.